Very good afternoon to one and all present here. I am welcoming you, all of you, to the fourth day of webinar series three, which is going to be on optimization using R. Before we start our today's session, let us start with our college prayer, followed by Tamil Thai Vartu.
கடலொடுத்த நிலமடந்து கெழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிழ் எக்கணமும் அதிசிறந்த திராவிட நல் திருநாடும் தக்க சிறு பிறைமுக தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
சத்யோரதம் சத்யபரம் த்ரிசத்யம் சத்யஸ்ய யோனிம் நிஹிதம் ச சத்யே சத்யஸ்ய சத்யம் ருதசத்யநேத்ரம் சத்யாத்மகம் த்வாம் சரணம் பிரபன்னாஹ. வாணி குணானுகதனே ஸ்ரவணோ கதாயாம் ஹஸ்தௌ ச கர்மசு மனஸ்தவ பாதயோர்நः ஸ்மிருத்யாம் சிரஸ்தவ நிவாச ஜகத்பிரணாமே दृष्टिः सतां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णाय अद्भुतकर्मणे रूपनाम विभेदेन रूपनाम विभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
Welcome back. I am extremely happy to introduce today's speaker, who is going to talk about on optimization using R. To talk about today's speakers, Dr. V.Parthiban. He is currently working in VIT Chennai as an assistant professor. He completed his PhD from Bharatiyar University. He also completed his MPhil, MSc from Bharatiyar University, BSc from Mahendra Arts and Science College. To talk about him, he is the man of tools. Whatever software you name it now, even if it is a new software, he will learn it, and next session you can see him giving a talk on that. Okay, so he is much interested in using tools for mathematics, and to talk about his experience, he is as I said, from 2015 onwards, he is working in Vellore Institute of Technology. Before that, he was associated with Bannari Amman Institute of Technology, and his area of interest in research, differential equations, fluid dynamics, control theory and numerical techniques. In teaching, it's engineering, maths, and statistical method. In terms of software skills, it is Python, Sage, MATLAB, mathematics, GeoGebra, R, and LaTeX. So we are welcoming you, sir, to give a lecture on optimization using R. Of course, this is a new dimension, exploring R for optimization. And the dais is yours, and please take over from here, sir. Give me a second.
Sir, am I audible, sir?
Yes, sir. Please go
Yes.
ahead.
Thank you, sir. Thank you. Very much. Thank you for a good introduction about me, sir. Nice introduction. Thank you. Okay. So before I start my lecture, I thank the organizer for giving me an opportunity for optimization. Okay. So optimization is an what is a very essential topic. Instead of saying a hot topic, it is very essential nowadays, because everything, if you take, either we need either a maximum or a minimum, we need an optimum thing. Okay. So what's the plan of today's lecture is, we are going to see how how a problem can be modeled in terms of an optimization problem. And once it model, how we can use an software called, or I'm going to use a software called, or which is displaying here. Okay, so we are going to use this software for solving that problem. Okay, maybe I will take some 2 to 3 problems if time, it depends upon the time. We will discuss an linear programming model, a transportation model, an assignment model. Okay, we will talk about some of these models. If there is more time, we will talk about network models too. Okay. Okay. So before getting into an optimization problems, let us see an software called R. Okay, so why this R is very important. Okay, so here is this is the home page. If you just type R in the Google, it will fetch you to this home page, which is rproject.org. Okay, so it's a very famous software. If you ask any data scientist or an working on big data analytics, whoever you ask, the first software they will be mentioning. Of course, there are plenty of softwares available there for data analytics, or say big data analytics, or machine learning, or deep learning. Say whatever the name you gave. Okay, so computer learning, whatever you name gave, this R will definitely a major part in that one. Okay, so this is because this is one of an best open source software to do your things. Either it may be an deep learning, or it may be an machine learning, or an data analytics. Whatever you take, R will be an best software. Why? Because you see, data analytics means nowadays data are not just like 100 or 200 data. We are going to deal with say big data, say a million of data, billions of data. We are going to deal with much more big data. Okay, so we need a software to handle this much of huge data. Okay, if you ask me whether we cannot do this kind of say data analysis using Excel, means no, surely you cannot. That is that is something like an word processor. Okay, so you can't do such an very big analytics, data analytics, using an a software like an Excel. Okay, so we need some specified software to do that one. Okay, so and R is the one of the first software will come to everyone's mind. Of course, you can do it in Python, but beyond Python, Python is a common software language. Okay, so mostly it is helpful for creating more number of softwares. Okay, but if you take this R, it is particularly for dealing with data. Okay, so that's why today, for today's session, I have chosen this R to do your optimization problems. Okay. Okay, so let me give a small introduction about this R, and I will move on to the optimization problem. Okay. Okay, so how to use this R means, say if you want to use it in the offline, I want to download and I want to use this, means you can go to this page and you can go to this CRAN. Okay, download CRAN on, yeah, it takes to the plenty of mirrors. Okay, so in any one of the mirror, you can download your software. Okay, so you can choose any mirror, not necessary it should be India. If you're in India, you can choose any mirror and you can download your software. Okay, so this is called CRAN mirrors, which is a comprehensive or RQ network. Okay, it is available for all kind of operating systems. You can use it for Windows, you can use it for Mac, you can use it for Linux, for any kind of thing you can use this R software. Okay, okay. If you install this R, it will open just like your command prompt. Okay, so if you install R and if you open means it will open as an just like an command prompt, just like a terminal. If you're using Linux means it will open just like a terminal. There you have to do all the things. Okay, so but it is not what is say, if you are a very beginner to use this software means working in command prompt is not an that much effective. Okay, so we need some specialized things, or we need some front end. Okay, so a nice front end means just like say click and play options. Okay, so if you're having say a pick, if I want to do something, if I click, if that one gives means, then that will be an what is a pleasant one. I won't say it is an effective one, it will be a pleasant one, so that there many number of users can use it easily. Okay, so we need some good front end for that one. Of course, there are plenty of front end also available for this R. Okay, so plenty of front ends are there, and one of the front end or IDE is R Studio. Okay, so if you just type R Studio in your Google, it will fetch you this one, R Studio open source. Okay, R Studio, it will take you this page. Of course, this R Studio is not only to work with R. You can work with many other things like R Markdown, some other things also you can work with this R. Okay, but this will be a nice front end for working with your R. Okay, so now these are all the solutions if you are using R in the offline. You are downloading and installing, and of course there is a what do you say, no money required to download these things because it's an open source. But sir, I am not having I am not going to use it in the offline. Okay, so I want some cloud platform to use this R. Okay, so means is there any cloud platform, is that just like say I'm having only a browser and I'm having an internet and I have to use this R, is there any cloud platform, is there? If you ask like that means yes, there is a cloud platform for R. As I said, there are plenty of cloud platforms to work with R, and there is an specified cloud is there for this R Studio itself. Say if you type R Studio Cloud, okay, so R Studio Cloud, it will take you to this page. It's loading. Okay, so here also you can create an account, like, or you can link with your Google account or a LinkedIn account or a GitHub account. Okay, so you can link with that one and you can create an account, or you can create a new thing also. Okay, it's an free thing, so you can create it here. So here I have created some projects of this R Studio, so you can work with this R, okay, in the cloud platform. Okay, okay, so I have installed R in my system. Okay, so this is the cloud platform. I will show a cloud platform how this one will look like. Okay, so because of this okay, internet connectivity, okay, so it takes some little time when you're working in the online, because it has to ping to the server and then it has to get back, no, so it will take little time. But once it's once we started our project, or once we started to work with a file, it will be fast as usual, but it will take some few minutes to restore my some old projects. Okay, I think it's restored. Yeah, it's working. Okay, so here is your thing. Okay, so I will close this menu. Okay, so this is your outline of your R Studio. Okay, say you will be having an menu bar where you can open your files, you can close your files, and this is your console. Okay, so this is your console where you can work with your codes. Okay, and there are some more windows are there. I will switch back to the offline version, and of course both offline and online versions are same. To have some good speed, I'm switching to the offline mode of this R Studio. I have installed R Studio in my system, so I will switch over to that one. Okay, 1 minute, I will stop share this screen. Okay, I will share that window. One minute, it's getting open. Yes. Okay, so now this is the general means the outlook of your R Studio. Okay, the main windows of this R Studio are here is your kernel, sorry, console or kernel, whatever you call. Okay, so here only we will be working with the codes of R. Okay, these are all some of the files like render jobs. These are all some of the files I have taken. Okay, so I can close these files. Okay, so I will close these things. Yes. So few minutes, I will close the everything so that it will be an empty screens. Okay, so now these four windows are the major windows of your R. Okay, so here you can enter your program. You can typeset your program. It's just like a programming language. How you use your Python or how you use your C or C++. Here, this R is also a programming language. You can write an program and you can execute the thing. Okay, so if you click on run, it will execute, and the output will be in this console. Okay, so you can create files. Okay, you can create a script file, notebook, markdown. As I said, these are all some of the other files. Okay, so this is just an IDE. Okay, so it's a place to work with lot other files also. You can work with your HTML files. You can work with your JavaScript files. You can work with your C files, etc. Okay, so not only our files, you can work with many more also. Like you can use, you can create presentations also using this one. Okay, you can create presentations. You can create documentation. So no need to go into some other thing. You can use your LaTeX codes also here. Okay, so that will be a very interesting thing. You can include your LaTeX codes. You can create the Beamer presentations. If you are very good at the LaTeX, means you can create the Beamer presentation for an R program. Okay, so inside an Beamer presentation, you can give your R code, and the output you will be getting. Like that, you can create many files, and these are all like usual menus. Okay, and here is your compile and run button. And this is just like the environment. Environment means what are all the variables I'm using, that will be listed here, and it can be cleared with this symbol. Okay, so this eraser symbol. Okay, so if you click that one, means what are all the variables you have saved here will be erased. Okay, and this is the list of commands which are previously used. That is the history of your commands. Okay, so these things would be missed if you use R in the console. Okay, so directly means if you directly use only R, means everything will be in the console. So you have to remember everything. You won't have this environment. You have this. You won't have this history. You won't have an file. Okay, so directly you have to work in the console. Okay, and next is this one. Say files means the directory where you are working, and plots. This plots is a very important thing, because visualization of data is very necessary. Okay, so once you have data, if you start visualizing the data, then you can easily understand that data. So to understand the data, plots are very much important. So if you create a plot for a data, then that plot will be displayed here. Okay, and from here you can export your graphs and all. Okay, you can easily create a beautiful graphs from R. Okay, and packages. Okay, so this is the one of the what is it? When you use an open source, this is the advantage. Okay, each and everyone will create their own codes. Okay, so for example, if I'm having a data and if I want to analyze that data, particularly for some purpose, if I want to analyze the data, what I will be doing is I will be writing a separate program. Okay, so that program can be uploaded in the R package that is called as an CRAN, comprehensive or archive network. Okay, so there I can share my program. Okay, so that is called as a package. I will be share that package to the CRAN, and they will be have a repository of that package there. So if some other people want to do the same thing, okay, if they want to do the same thing, means they can directly fetch the corresponding package from that CRAN network. Okay, so here it will be there. If I want to install some package, okay, let's say for today I'm going to use a package called lpsolve. That lpsolve is not a default package of R. Mostly many of the packages won't be default in R. We have to install it, we have to use it from you have to fetch it from the CRAN, and then only you have to use it. Okay, say if I want to, if I want a package, okay, so if I want lpsolve, okay, so just solve lpsolve, or there is another package also called lpsolve API. Okay, so click on that lpsolve, where from where I have to fetch, I have to fetch it from an repository, or you can make it as a separate package. From that package also you can use it. Okay, so means say privately you are writing a package in R, and if you are circulating among your friends, and if you want to use that one, means you can install that package from personally also, or you can deposit that one in the CRAN repository, and from there also you can fetch your things. Okay, so if you want lpsolve, means type whatever package. Okay, so this is lpsolve is the package what we require today. Say for some other purpose you can use some other packages, and you can click that install. Okay, okay, so it's already installed, so it is asking say like that. Okay, I may install a new package. Okay, so lpsolve. Okay, so that is lpsolve API. Okay, so if you want to install a package from the console, then you have to give this one, install.packages of which package you want. Okay, so this command you should know. Okay, maybe I will increase the font size. Okay, of course for today's session we don't need of these things, so just I will hide those things. Okay, so it will fetch from the CRAN network, and it will install in your systems. Because actually it's working, it's downloading. Okay, so it will download like this. Okay, and it will be stored here. Okay, so if you want to use that package, then choose that, search for that package here. Okay, so today I need lpsolve. Okay, so choose for that package and click this one. So if I click one, means say library of lpsolve. So what are all the commands available in that lpsolve? Now I can use that one. Okay, so what are all the commands available? How to check that one? Click on that lpsolve. It will automatically take you there. Okay, so the documentation of that lpsolve. So these are all the different functions available in the lpsolve. Okay, so we are going to see today. Okay, so LP assignment problem, LP transportation problem. Okay, so like that we are going to discuss it today. Okay, so for time being, I hide every this, and I'm going to deal with this thing. Okay, so this is an general introduction to R, and how to use this R. Say like say a equal to 2. Okay, so what I'm doing here, I'm assigning a value to a. Okay, sir Hariran sir, is this font size is okay, or I have to increase it a little bit?
Yes, sir, that seems to be okay. Not an issue.
Not an issue. Okay, sir, thank you, sir.
When it comes in YouTube, it will be good. No issues.
Good.
Okay.
Thank you, sir.
Yeah.
Thank you, sir. Okay, anyhow, I will because I'm going to keep only this window, so I will increase as much I can. Okay, so here what I'm doing, I'm assigning a variable, assigning a number to a variable like a equal to 2. Say if I assign b equal to 3, you see now it's a very simple like things. You can add the variable, say a plus b, so it will gives me the answer. You can perform uh, operations, mathematical operations like assigning something, or directly also you can do like say 6 plus 10, like this also you can do the things. Okay, it's just like your normal calculator. Okay, so like say 5 plus 9 minus 15 into 36 divided by 5. Okay, so like this you can perform an operation. Okay, uh, sir, am I visible, sir?
You are audible, sir. You are in the other link anyway. No issues. You can continue.
Okay. My screen is visible now because in
Screen is
another.
visible. Screen is
Yes, sir.
visible. Everything is good. Don't worry.
Yes, sir, sir. Because suddenly in other device it got disconnected. That's why
No
I'm
issues.
asking.
No issues. Yeah,
Thank you,
please
thank you, sir.
continue.
Okay, so like this you can perform mathematical operations. The thing you can use say sign off thing let's say, like this you can perform some you can use trigonometric things, but remember this or is not to do your mathematical. It's not a mathematical software actually. Okay, it's a programming language. It's used for work with some data analytics, big data analytics. It is not an software like MATLAB. Okay, so it means if you ask to perform say derivatives integrations, whether if you ask me whether it will perform a derivative or it will perform an integration or it will perform some symbolic computations or say a graph theory problem can be done here means no, it's not an software. It is developed for working with symbolic things. Okay, so it's a software for data analytics. Okay, so don't write. Of course there are some packages. Okay, so it is not entirely you cannot do the things you can do. You can do some derivatives, you can do some integrations at a limited thing. Okay, so for a limited thing you can do that those things. Okay, so but it is not built for that one. The main aim of this one is to do what is it, to work with your big data. Okay, so that kind of problems can be done. You can easily create a package with that one. Okay, okay, so this is how an or will work. Okay, so now you can install an or from that grand network, or if you want you can work with that online version also, that R studio. And or just if you type or online means there are plenty of other places also to work with or on the cloud. Okay, so this is the power of or advantages of using open source software. Okay, so when you are going for like a closed source like MATLAB or let's say Mathematica, there will be a cloud support, but you won't have what is it, you need some proper you need to pay for that company, you need licenses to work that one. Okay, so but this is free, so that's why it is available in many things. And say if you are creating an website, so for example if you are creating a website and in that website, so if you want to embed your R code, okay, means the user who are any new user who are coming inside want to work with some of the R codes in your website means you can embed an R here. Okay, so you can embed a box and there you can means the user who is visiting your website can work with R here. Okay, you can embed the things. Okay, so these are all the advantages of using open source, and these things are you can easily done with this R. Okay, so with this introduction, of course already half an hour is over, so with this introduction I will move on to the uh, operation research, means an optimization problem, how an optimization problem would be. Okay, so to give an introduction about that optimization problem, I will share an uh, a book. Okay, maybe from now onwards I will share the my entire screen, so I will be navigating from the book and this art studio. So I will share my entire screen. Okay, so I'm going to share my entire screen, so it won't be that much what is say good if you are moving from one thing to other, but it will be easy for me to navigate from the book and the thing. Okay, okay, 1 minute, I will take a problem. Yes. Okay, so what is an optimization problem? What do you mean by an optimization problem? Okay, so this subject, okay, so this operation research, okay, so optimization problems are an part of this operation research. Okay, so this starts at the during the World War. Okay, so during the World War II, this subject gains more importance. Okay, so because of this applications in variety of fields. Okay, so it is not only applicable only in that during that war. It has been extended to anywhere, because anywhere we are having the maximization or minimization problem, means an optimization problem. Okay, so here is an example. Okay, so a perfect example of an optimization problem. Okay, say this is an data of a company. Okay, so whatever we are having, that is a data. Okay, so what is the data? So without studying this one, let me explain from this one. Say a company or a factory is having three missions. Say we are having a mission X, we are having mission Y, and we are having mission Z. We are having three missions, and the factory is producing two products. Okay, using these three missions, the factory is producing two products, say product A and product B. Okay, so this is the thing. So this is the scenario of an factory. A factory is having three missions which is producing two products, product A and product B. Okay, and say if you want to create a product A. Okay, so if you want to create a product A, say for example you are creating a cloth. Okay, suppose a cloth manufacturing company. Okay, so to create a cloth, first from the cotton a thread has to be generated. From the thread a cloth should be generated, and from the cloth it has to be stitched. Okay, so suppose these three things are done by three different missions. Okay, so mission X will separate or will create thread from an cotton, and the same mission Y will from the thread it will create a cloth, and same mission Z will stitch that cloth. Okay, so suppose these three things. Okay, then each mission or to create that product, it has to be processed in each mission at for some time. Okay, so for example, this to create a product A, it has to be processed in mission X for 10 hours. Okay, similarly it has to be processed to 5 hours in mission Y, and it has to be processed 1 hour in mission Z. Okay, so this is the what is the time required by a product to get an entire product. Okay, so like that, if you create a product A, the profit from that product is 23. Okay, so the profit from that product is 23. Similarly, the machine is producing another kind of product called B. So this is the data. So if you want to create an product B, it has to be processed in machine X for 6 hours, and it has to be processed in machine Y for 10 hours, and it has to be processed in machine Z for 2 hours. Okay, so like that, if you create a product B, then the total profit is 32 rupees. Okay, so now this is the data, but here you see we cannot use the machine always. Okay, so there will be some constraint for that machine. Okay, so means a machine cannot be run for continuously for 200 say 24 hours by 7. Okay, so there will be some restriction for that. Okay, what is that restriction? See here, that restriction, that machine X will work only 2500 hours. Okay, so similarly machine Y will work for 2000 hours, and machine Z will work for only 500 hours. Okay, so now this is the constraint. Okay, so this is called as constraint, because this will be there in every whatever situation is there, you will be having some constraint on that one. Okay, so either it may be a machine, or it may be a manpower, or it may be a natural resource, whatever thing, you will be having some restrictions on that one. Okay, so that is called as an say, constraints. Okay, so this is called as a constraint, and this is the cost. Okay, so if you create a product, you will be having some profit from that. Without a profit, no need to create that, right? So you will be having some. So this is called as a cost function. Okay, so this is called as a cost. Okay, okay, so how to model this one? This is very important. How to model this one in terms of equation? Okay, so once you model in terms of equation, then you can easily solve. Okay, so if you model this one, so what I have to do, I have to maximize this profit. I have to maximize this profit. Okay, so what is the profit? 23 rupees from product A and 32 rupees from product B. So this is my profit. So I have to maximize the thing. So here is the thing. So I'm going to maximize 23A plus 32B, where A and B are number of units produced from product A and the number of units produced from product B. Suppose I'm producing A units from product A and I'm producing B units from product B, then the total profit will be 23A plus 32. Okay, so I have to maximize this one. Okay, so this is called as an objective function. Okay, so this is called as an objective function. Okay, simply we cannot say, okay, so if A and B are infinity, my profit will be maximum, right? Say if I produce infinite number of unit of product A and infinite unit of a product B means then my profit also infinity, but that is not possible at all. Okay, so we can create only something, because we are having constraint. We have to process those products in these machines and we have constraint on how many hours we can use that machine. Okay, so like that we're having constraint. Okay, so now this is called as constraint. Okay, so what is that constraint? Say if I create or if I produce A products from this A unit from this product A and 6 units from product B. Okay, so then I have to process that much hours. How many hours from machine A? 10A times. Okay, so if I create A units from this product A, then it has to be processed 10A hours in machine X, and B units from product B means then it has to be processed 6B hours, right? So it is 10A plus 6B, 10A plus 6B. Okay, so the total hours, okay, so this 10A plus 6B should be less than 2500, should be less than 2500. Okay, so similarly if I create A units from product A and B units from product B, then it has to be 5A plus 10B, which is that should be less than 2000 hours. Similarly, say if I create A units from product A and B units from product B, then A plus 2B should be less than 500 hours. Okay, so now this is my problem. Okay, so this is my problem. Okay, so and of course this is called as a non-negativity constraint, because there is no possibility of without either we can what do you say create a product at least 0. It cannot be negative, no? So number of products cannot be negative, so A and B should be positive. Okay, so now this is called as an optimization problem. Okay, so this is an optimization problem, and of course it's a linear programming problem. It's called as an LPP. Okay, so it's a linear programming problem, because all the variables here I am considering are linear. Okay, so here I am not considering any A squared or B squared. Here it is nothing is non-linear, everything is linear. So it is a linear okay, so details are hidden while you share your screen. Sir, which details are may I know, sir, so that I will rectify here. So Hariharan sir, is any other details are hidden or screen is shared?
Uh, your uh, your book is shared actually,
Yes.
but it is coming actually. You go to the other screen.
So actually I have shared my entire screen, sir.
Yeah, fine, fine. That is coming. You can go ahead.
Yeah,
No
okay. So because
issues.
they have pinged that something has been hidden, that's why I asked.
No issues. No issues.
Thank
Yeah.
you, thank you. Okay, so now this is my problem, which is called as an linear programming problem. Okay, so because every variables are linear, it is called as a linear programming problem, and this is an example of an optimization problem. Okay, and of course here it is an maximization case. Here we are maximizing the profit. It is not necessary. It is it should be maximized every time. Okay, so sometimes we need to minimize something. Say if this is say for example traveling time. Okay, so suppose if you are modeling in terms of traveling time, there you have to minimize your time. Okay, so likewise it depends upon the scenario whether it is you are going to maximize your profit or you are going to minimize your time, like that. Okay, so here it is a maximization problem. So the problem is maximize is at 23A plus 32B subject to the constraint 10A plus 6B. Hope you understand how this thing is created. Okay, and of course there are plenty of methods are there to solve this linear programming problem. Okay, so here if you take the famous thing is simplex method. Okay, so this is a simplex method and they have solved that one. Okay, so I'm not going to teach this method to solve this, how to solve this problem. Okay, so here I am considering how we can solve this problem using R. Okay, I'm not going to consider about how we are going to solve with the help of pen and paper. Okay, so that is not our thing here. So I'm going to use the R software to solve this problem. How to solve this problem? Okay, so let me go back to my R studio. Okay, so now this is my problem. Maximize z equal to 23a plus 32b. So first let me insert my cost function. Okay, so let the CF represents the cost function. Okay, so CF is, okay, so here if I want to give something, means in terms of array, I will be using a thing called C. Okay, so C means it will combine what are all the values I'm going to here and save it in CF. Okay, so CF is my cost function. Okay, so what is my cost things here? 23 and 32. So 23 and 32. Okay, so this is my cost function. Okay, so 23 comma 32. So this is my cost function. Okay, so if you look into CF, it will show. Okay, so 23 and 32 are my cost function. Okay, next is I'm going to give this matrix. Okay, I'm going to give this because this is a matrix. Okay, so if I say in terms of mathematics, this is nothing but maximize z equal to Cx. Okay, so maximize z equal to Cx, where C is the cost matrix and x is the variables a and b. Okay, so here it is 1 by 2, C is 1 by 2, and x is 2 by 1. So resultant will be an 1 by 1 matrix. Okay, so maximum z equal to Cx, subject to the constraint Ax less than or equal to b. Okay, Ax less than or equal to b. Okay, so if I talk in terms of matrices. Okay, so the problem is maximize z equal to Cx subject to the constraint. Okay, so this is my constraint. Ax is less than or equal to b. Okay, so now I'm going to give my matrix A. So what is my matrix A? 10, 6, 5, 10, 1, 2. So this is my matrix. Okay, so how to give that matrix? Okay, so let me store it in A. So A is equal to, I'm going to create a matrix. So matrix of C, I'm going to combine the values. Okay, so what are all the values? 10, 5, 1, 6, 10, 2. Okay, so these are all the elements of that matrix. 10, 5, 1, 6, 10, 1 are the elements of the matrix with number of rows. Okay, so this is the command in R to create a matrix. Okay, so how many rows are there? Here I'm having 3 rows. Here I'm having 3 rows. Okay, so now this will create me a matrix with these elements with number of rows as 3. So if you look into this matrix, this is nothing but 10, 6, 5, 10, 1, 1. You can check it here. 10, 6, 5, 10. Oh, it's 1 and 2. Okay, so it should be 1 and 2. Okay, so 10, 6, 5, 10, 1 and 2. Now this is my matrix, A matrix. Okay, so I have entered my cost function. I have entered my matrix. What else I have to enter? I have to enter what is this B value, right? What is this? The B value. Okay, so what is that B value? Which is nothing but C of 2500, 2000, and 500. Okay, so now this is my B matrix. So I have entered my cost function. I have entered my A matrix. I have entered my B matrix. If you want, you can look at that B matrix, which is 2500, 2000, and 500. Now I have to enter my sign. It is not necessary that always it should be less than or equal to. There may be a problem with mixed signs also. For minimization problems, the standard LP is it is greater than. For maximization, it is less than, and for minimization, it should be greater than. But you may have cases where some things are lesser than or equal to, some things are greater than or equal to. That mixed signs also in some problems it may come. Okay, so we have to give that what is the thing? The signs also. Okay, so if I give that sign, okay, so let me take it as a sign. Okay, so sign is what are all the signs I'm going to use. Okay, so it is already there. Okay, so let me use it as signs. So signs equal to. So everything is less than or equal to. Okay, so the first constraint is less than or equal to. Similarly, the second constraint is also less than or equal to. And third constraint is also less than or equal to. Okay, so now these are all my signs. Okay, so now I have formulated all the problem. Okay, so I will show it from here. Of course, if I remove everything also, it will be saved, it won't go there. Okay, so my cost function is 2332. My matrix is this one. A matrix is 10 6 5 10 1 2, and my B matrix is 2500 2000 500, and my signs, okay, signs is less than or equal to, less than or equal to, less than or equal to. Okay, so now I'm going to formulate the problem. Okay, so the problem is, okay, so how a LPP can be entered in R is by using the command called LP. Okay, so LP, which is a linear programming. Okay, so LP is the command to enter a problem. Okay, so problem is LP, linear problem of using which one. Okay, so first I'm going to say whether it is an maximization problem or an minimization problem. So for maximization problem, I will be giving MAX. For a minimization problem, I will be giving MIN. Okay, so here it is a maximization problem, so MAX. Okay, so I'm going to maximize the cost function. Okay, I'm going to maximize the cost function for the matrix A with the signs. Okay, so with the signs with the constraints B. Okay, so LP of max cost function, the A matrix, the signs, and the B. Okay, so now this will be my problem. Okay, so this will be my problem. Okay, so if you look into the problem, it will show. Okay, so it directly gives me the answer. Of course, this problem has many attributes. Okay, so what do you mean by attributes? Say how to get the attributes. Attributes means, say if you take an Excel file. Okay, so in Excel file you will be having a lot of tabs, no, like that. That is an attribute. Okay, so like Excel file having plenty of tabs, here also a variable can have plenty of attributes associated that one. Okay, so how to get that attribute is nothing but if you place an dollar. Okay, if you place an dollar, it will show what are all the attributes associated with that problem. Okay, so now these are all the different attributes. Okay, and if everything is not necessary for us. Okay, so it depends upon in which point of view you are looking into the problem, which data you want that problem, it depends. But usually what we need the solution, right? We need the solution of that problem. Okay, so the solution, so problem of it. Okay, so now this is my solution. Means I have to create 185.7143 products of product A and 107.1429 products of product B. Of course, if it is a product, it should be an integer, right? Because you cannot create a product of with decimals. You cannot create a product with decimals. So it becomes an integer programming problem. Okay, so beyond that LPP, it became an integer programming problem. And of course, there is a separate command, is there, separate package is available to solve your integer programming problem. So means the answer will be integer. Okay, so but in general, if you solve, this is your solution. Okay, so means if real numbers are allowed, so this is your solution. Means we have to produce 180, so approximately 186 products of product A and 107 products of product B. Okay, so this is it. And what is the objective function? What will be the maximum cost I can obtain is, so that you can obtain from problem of say objective value. Okay, so objective value, OBG, so objective value. So the objective value is 7700. So the maximum profit I can obtain for that problem is 7700. Okay, and how much product I have to produce? This much product I have to produce. Okay, so this is an example of a maximization problem, and this is how you can solve your problem using R. Okay, if you look into how you can solve with the help of pen and paper, means the simplest tool is that is simplex table. Okay, so this is the simplex table. Here you have to do iterations and all. Okay, so if you are already, if you have studied the 2 or paper, means you might know what is this thing. Okay, so you have to do the iterations. Okay, so this is the iteration they have given, how to do that iteration. Okay, so it's going on here. Okay, so it's going on here. Okay, so it is like this, it is going on here. So here got the same answer, it is 7700. 100. Okay, so here we are creating producing 185.7 and 107.14, the same answer what we have got, 185.7 and 107.14. Okay, as I said before, there won't be necessary that always problem should be a maximization problem. You might have an minimization problem also. Okay, say for example, here is your problem. Okay, um, so a doctor is say suppose a patient here, a patient is visiting a doctor, and a doctor suggests to the patient to take uh, some minimum say vitamins is less in his body. Okay, so you have to take some vitamins. Okay, so to take, so he need vitamin A and vitamin B. Okay, so minimum of say you can take it as and say 40 units and 50 units. It is maybe 40 ml or 50 ml, like that you can take. Or if you talk in terms of months, it may be an 40 ml or 50 ml, like that you can take. Okay, so that 40 units of vitamin A is required and 50 units of vitamin B is required. Okay, so how to get that vitamin? He suggests two different tonics. He suggested two different tonics. Okay, a tonic X and a tonic Y. And from tonics X, okay, so if we consume that tonic X, you can have 2 units of vitamin A. You can have 2 units of vitamin A. Similarly, if you consume tonic Y, you will have 4 units of vitamin A. It look like, say, for getting 40 units of vitamin A, directly you can consider 10 units of tonic Y. You can think it of like that. But the constraint here is, see the cost. Okay, so here this the cost. Okay, so it means tonic X cost 3 rupees and the tonic Y cost 2.5 rupees. Okay, so now what will be the problem? As a patient or as a person, what you will be thinking, I have to minimize the cost of the tonics I'm using. Okay, you can use the combination of both the tonics. So I have to decide in which combination I have to buy the tonics. Means how many units of tonic X should be buy and how many units of tonic Y should be buy, right? Because you see tonic X cost is 30 rupees and tonic Y cost 250 2.5 rupees. Okay, and this is the composition. Okay, so in tonic X, you will be having 2 units of vitamin A and 3 units of vitamin B. Whereas in tonic Y, that vitamin A is higher. You are having 4 units of vitamin A, but you will be having only 2 units of vitamin B. You see, here is the thing. And the requirement, the total requirement is you must surely take 40 units of vitamin A and 50 units of vitamin B. Okay, so if I model this problem, okay, so if I model this problem, then what I have to do, I have to minimize my cost. I have to minimize my cost. Okay, so what is the cost here? Suppose if I buy X units of tonic X and Y units of tonic Y, then I have to minimize the cost, which is 3X plus 2.5 Y. Okay, 3X and 2.5, oh, sorry, 3X and 2.5 Y. And what is that constraint? My total input of vitamin A should be greater than or equal to 40. You see, in the last problem, it is less than or equal to, but here is greater, because minimum I need 40 units of vitamin A. So it should be 2X plus 4Y must be greater than or equal to 40. Similarly, vitamin B, which is 3X plus 2Y, should be greater than or equal to 50. Okay, so this is your minimum requirement. So for minimum case, you will be having greater than or equal to. As I said, the standard thing is for a maximization problem, you will be having less than or equal to. For a minimization problem, you will be having greater than or equal to. Okay, but it is not necessary. You can have the mixed thing also. You can have greater than less than, or you can have an mixed of greater than and less than signs. Okay, so now this is my problem. Okay, so how to solve this problem? Quickly I will input the values. Sorry, yeah, I will delete that console. So my cost function is C of 3 comma 2.5. So this is my cost function, and the matrix A is matrix of C of so what are all the values? Oh, sorry, something has been open. What are all the values? 2, 3, 4, and 2. 2, 3, 4, and 2. And the number of rows. N row represents how many rows you are going to create with this array of elements. Okay, so I'm going to create 2 rows, so n row of 2. Okay, so this is my matrix and the signs. Okay, so what are all the signs? Which is nothing but all are greater than or equal to. Okay, so there are 2 equations and the 3 equations are greater than or equal to. So this is my signs and the B matrix. Okay, so the B matrix is the minimum requirement. I think it is 40 and 50. 40 and 50. So this is my minimum requirement. Okay, so this is my problem. Okay, so the cost function is 3 comma 2.5 and the matrix A is 2 4 3 and 2. So this is my matrix and the signs are both are greater than or equal to, and my constraints are 40 and 50. Okay, so how to frame the problem? So the problem is given by LP. Okay, so LP of, here it is a minimization problem. Here it is a minimization problem. So it should be MIN. Okay, it should be MIN. Minimum of the cost function with the A matrix with the signs. Okay, so it is greater than or equal to signs with the constraint. So now I have constructed the problem. Okay, and if you want to see the answer, so problem of, okay, so once you constructed the problem, all these attributes will be created. Okay, so I don't want to go deep into each and everything. Okay, so all attributes will be created. Okay, and the main attribute we want is say object value. Okay, so object value. So it is 51.25 means the minimum amount I need to buy those 2 tonics to satisfy my requirement of vitamins is 51.25 rupees. So this is my cost, 51.25 rupees. And how much units of tonic X and how much units of tonic Y should be bought? That can be obtained by using problem of solution. Okay, so I have to buy 15 units of tonic X and 2.5 units of tonic Y. Again, it's an integer problem. Okay, so because you cannot buy an 2.5 bottle of tonic Y, that is not possible. Okay, so it again became an integer programming problem, and as I said, there are some other packages are there to solve your integer programming problem. Okay, so but it's generally this is your answer. Okay, I will show the answer here. I don't know whether they have solved it here or not. Yeah, I think they have solved here. Okay, so you see my thing is 51.25 with the 15 units of X and 2 units of Y. And you will appreciate how this R is working if you already done these simplex tables. Okay, so you know the pain of how much you have to work with this one to get that answer. Okay, so it has been programmed nicely, and you can, and of course this is R is not actually designed to do this kind of simple problems. Okay, it's a very simplest problem, and it is not a simplest problem in the sense only few variables are there, only X and Y, only 2 variables are there. But when it comes to the real world, it looks like a real world problem, but it's not an actually a real world problem. It is an constructed problem. Okay, so when you look into that real world problem, there are only 2 variables. You will be having plenty of variables associated with that one. Okay, that means the variables will be big data. You will be having a lot of parameters to work with that one. Okay, so there you need to deal with that big data, like say if you take an data of an Google. Okay, so everywhere it's an optimization only, either it may be an dealing with the Googles or say whatever you take. Okay, so there you will end up with a lot of data. So, okay, so to analyze those things, anyhow it's going to be an optimization problem only. Whatever you take, it's going to be an optimization. Say for example, if you take the Google Maps. Okay, so there among the many things, you have to find which one is having minimum shortest route. Okay, so that is an minimization problem, or you have to find minimum time. Okay, so it's again an minimization problem and optimization problems. Okay, so there it won't be only 2 variables or 3 variables. You will be having plenty of variables, and it's not possible to work it in hand. Okay, not at all possible. Okay, so you need a nice software, and R is one of the best thing. Okay, okay, so I will quickly do one more problem. So Harian sir, shall I take some 5 more minutes, sir?
Please continue, sir. No issues.
Yes, okay. So I will take I will explain one more model, maybe assignment model and transportation model. Quickly, I will do this one. Okay, I won't take much time. Okay, so here is an problem. Okay, so here it's again an optimization problem. Means say we are having 3 jobs. Okay, so job A, job B, and sub B. We are having 3 jobs, and we are having say 3 missions, X, Y, and Z. Okay, so X, Y, and Z. Okay, and this is the time means taken. Okay, so the X mission will take 11 hours to complete the job A. Y mission will take 16 hours to complete job A. Similarly, the Z mission will take 21 hours to complete the same job A. Okay, so likewise, the time is given. Okay, so the time is given. So if this is the thing, what we have to do, we have to find to which mission we have to assign which job. Okay, so that the total time will be minimum. Okay, so with the minimum time, I can finish all the jobs. Okay, so that is the problem. Okay, so we are having 3 jobs, we are having 3 missions, and this is the time given. Say if a job A is assigned to mission X, then it took 11 hours. Let's say similarly, if job A is assigned to mission Y, then 16 hours are required. Okay, so like that, the time, this is the time matrix has been given. So we have to minimize the total time, and we have to find which job has to be assigned to which mission. Okay, so how we can solve this one? It's again a minimization problem. Okay, and I don't want to go into the formulation of the problem because we are having directly the matrix. So I'm going to enter the matrix as it is. Okay, so let me note down the matrix. It is 11 20 13 16 13 15 21 17 12. So it will be easy for me to enter there. Okay, so the time matrix. Okay, so let Tm represents the time matrix. It is a matrix of C 11 20 13 16 13 15 21 17 and 12, and the number of rows here is 3. We are having 3 rows. Okay, so if you look into the time matrix, so this is my matrix 11 20 13 16 13 15 21 17 12. Okay, so now this is my time matrix. Okay, so now I have to find which job has to be assigned to which mission. Okay, so the command in or to solve this problem is lp dot assign. Okay, so there is a command in that lp package which is called lp assign. Okay, so lp assign means it will give. Okay, so the cost matrix or time matrix. So time matrix, so it will solve, because usually we have to minimize the time. No, there are some problems where you have to maximize the thing also. Say if it is instead of time, if it is the profit, then there we have to maximize the profit. Okay, so like that, sometimes you will be having maximization problem also. So in that case, you have to mention it is a maximization assignment problem. Okay, so but if it is by default, it is an minimization problem. So no need to define if it is an minimization problem. So lp dot assign of p. Okay, so here it has been solved. Okay, so let me solve that. Maybe save that problem in a variable lp dot assign of t. I will save that one so that I will get all the attributes of that problem. Okay, so problem, say solution. Okay, so what is the solution? So this is my solution. Means the first job should be assigned to mission X. The second job should be assigned to mission Y, and the third job should be assigned to mission Z. Okay, so that is the meaning. Okay, and what is the total time required? How I can find? That is problem of objective value. Okay, so the total time is 36 hours. Okay, so like that you can solve an assignment problem. Okay, and I will end my talk with an example for transportation problem. Okay, so with the transportation problem, I will end my talk. Okay, what do you mean by a transportation problem? I will show a problem and I will explain you. Okay, so this is a transportation problem. It's something like your LPP, like your linear programming problem. Okay, say we are having 4 different factories A, B, C, D, and 3 different markets X, Y, Z. Okay, so what we have to do is we have to distribute the products from these products to the markets. We have to transport the products from these 4 factories to these three markets. Okay, say if I transport a unit from factory A to market X, then I need 4 rupees. You can take it as an cost in terms of 100, so it is 400. It takes 400 units. So to transport a unit from factory A to market X, I need 400 rupees because it is given in terms of 100. Similarly, if I want to transport a product from factory B to product X, then I need 500 rupees. So like that, it is the cost matrix is given. Okay, and there will be a constraint that and how many products can be what do you say manufactured in a factory. Okay, so that is your availability. Okay, that is means you can able to transport only 10 units from factory A. You can transport only 8 units from factory B. You can transport only 5 units from factory C, like that. Okay, so this is the availability. From each factory you can transport only few amount of things. So this is your availability, and each market will have some requirement, right? Say this market X needs minimum of 7 units. Similarly, this market needs minimum of 12 units, and this market needs a minimum of 4 units. Okay, so you will be having some what do you say some requirements. Okay, so now this is the problem. Again, I'm not going to go into the formulation of this problem. Okay, so just I'm going to show how we can solve this one using R. Okay, so first let me input the cost matrix. Okay, so the cost matrix is matrix of C of, okay, so 4 comma 5 comma 6 comma 3 comma 3 comma 6 comma 4 comma 5 2 comma 1 comma 3 comma 4, and number of rows is 4. Okay, so let me check the cost matrix once again. 4 5 6 3 3 6 4 5 2 1 3 4. Okay, so now this is my cost matrix. Okay, and after entering the cost matrix, I have to give what is row sign. Okay, so what is that row sign means? You see here, from factory A I can transport only 10 units. Okay, so which is I cannot transport more than 10 units. Similarly, from factory B I cannot transport more than 8 units because the availability is only 10 8 5 and 6. Okay, so this should be that row sign. Okay, so this is okay, so this is column 1. Okay, so let me take it as an column sign. Okay, so the column sign is column sign. Okay, so the column sign is it's having maximum of 10. Okay, and it is having maximum of 8, so it should not means the number of units you are transporting from factory A should not exceed 10. Okay, so it is less than or equal to 10. Okay, you cannot go more than that one, so it should be less than or equal to 10. Okay, so everything will be less than or equal to, here also less than or equal to, here also it is less than or equal to. Okay, and row constraint. Okay, so let me take it as a row constraint. Okay, so what is that row constraint? Say 10 8 5 1. Oh, sorry, column constraint. It is not row constraint, it is column constraint. Okay, so column constraint. Okay, so what are all the column constraint? 10 8 5 and 6. 10 8 5 and 6. So this is my column constraint. Similarly, I have to give what is the row sign. Okay, so row sign is equal to C of, here I need minimum of 7 units, minimum of 12 units, and minimum of 4 units. Okay, so I have to give that one. Okay, so minimum means it may be greater than or equal. It should be minimum 7 units, but it can be more than that 7 units. That is the requirement. Okay, so it is greater than or equal to, so greater than or equal to. So this is my row sign. And what are all my row constraints? Okay, so row constraint is C of 7 12 and 4. 7 12 and 4. So this is my row constraint. Okay, so now I have entered all the details about the problem. So let me construct the problem. So problem is problem is LP. So it's a transport problem. So LP dot transport. It's a transportation problem. So LP dot transport. First, I have to give the cost matrix. Okay, so it is CM, and whether I have to say it's a minimization or maximization. As I said, it is not necessary always it should be minimization problem. Okay, it sometimes may be a maximization. It depends upon the scenario what we are taking. Okay, row sign. Okay, so column sign, column constraint. Okay, column constraint, row sign, row constraint, row constraint. Okay, so now I have constructed the problem. Okay, so now once you constructed the problem, then you can get the answer for the problem using say problem dot say objective value. Okay, so obj value, which is an objective value, so which is 65. Okay, so means the total transportation cost is 65. Okay, and how many units has to be transported from each one to each one, how to find that one, that is obtained by problem of solution. Okay, so now it will give us, say I have to transport 1 unit from factory A to the market X. I have to transport 9 units from factory A to market Y. 4 units like that. Okay, so this is my your transportation. Okay, so this is how we have to transport. Say from directly from a market, sorry, from factory B, you can transport 4 units to market is up. Okay, so this may be less transportation cost because of that. Okay, and again, if you do it in the hand, it's a very lengthy process. Okay, so it will be going on like this. Modi method will be involved. Okay, some degeneracy will be involved. Okay, so like that it will goes, and finally you will be getting the answer. And I think we got the same answer. Let me check. I don't know. Yeah, here it is, 195,367. That's 195. Okay, so like this you can solve your transportation problem. Okay, and of course you can solve a dynamic problem here. You can solve a network problem here. You can solve a game theory problem using R. Okay, and again, it's not only for dealing with these few variables. Okay, so in real world it is not the case. It is not like only 3 variables or 4 variables. These examples are given just to explain the concepts. Okay, so but in real world it will having, it is a data, it will be a file. Okay, it will be a like a data file. Okay, so you have to input your data file. Instead of here I'm giving columns and constant like that, no, instead you have to give your column that data file. Okay, so once you input your data files here, you can get the answer. Okay. Okay, so I will stop the lecture here, and if you have any doubts, you can ask. Sir Hariran sir, where I have to see the doubts?
Yeah, we will get it in chat box. One thing is it possible to see the intermediate steps in R?
No, sir. That is not yet implemented in R. You cannot see that implemented step. Maybe you can visualize that graphical method. We will be using graphical method for 2 variables, no? So that one you can visualize, but you cannot see the simplex tables here. I think you were asking about that simplex tables, right?
Yes,
Yes, and that
exactly.
simplex table you cannot see it here, sir.
No, not only that, in transportation or assignment, we
Yeah,
have
and
the
all these things
intermediate.
because they're using some high level algorithms. Usually they won't use this northwest corner or Moody algorithms as an algorithm to write here. They will be using some higher level algorithm, so that is not possible to see those intermediate steps. So
Yes.
if you want to look into the intermediate step, I think there is an website called A to Z Math. There you can see the intermediate steps. Maybe if you are interested, I can show that one because it may be useful for college students. So here you are having an operation research. Say if you are using an assignment problem. So here everything will be listed like assignment problem, simplex problem. Here you see, suppose this is your assignment problem. Yeah, it will show the intermediate steps. Step 1, step 2, what you have to do. Like that it will show. And as I said, in real worlds, we won't deal with only these 2 variables or 3 variables. We will be dealing with big data. Okay, so it has been designed to solve those big data problems. So there is no need to visualize what is happening in between.
Participants, do you have any other questions to ask? Please post it in the chat box so that sir can answer.
This is here it will show that intermediate steps. This one.
Yeah. Yes.
Yes. Like I have to subtract the maximum value from each and every number. So we have to select each one. So that will be shown here.
Yes. Yeah. Thank you. Yeah. Any other question from participants? Yeah. As there is no question, I take this opportunity to thank our resource person, Dr. V.Parthiban. Of course, this will be a nice session if it is hands-on, but through online mode we are doing. So it's a good thing to know about implementation of optimization problem in R. I take this opportunity to thank our management for giving this opportunity to make this webinar happen. Uh, I take this as a pleasure to thank our secretary, Shri Ashok Kumar Mundraji, our principal, Dr. Santosh Babu, and our head of the department, Professor R. Venkatramanan. Of course, I take this a special thanks to the resource person, Dr. V.Parthiban, for giving us a wonderful lecture on optimization using R. So it gives us a new dimension of working with optimization problem using a software or anyway, and which is useful for everyone. Thanks a lot for giving us this wonderful lecture, Parthiban. It's almost look like a hands-on session, but only thing is the online mode makes this as the webinar. Thanks a lot, Parthiban, for giving this. And of course, I thank all the audience for seeing this. Thank you so much. So the feedback form will be posted through to your email. You can fill the feedback form later. Thank you so much. So let us wind up the today's session. Thanks a lot.